Finding the 6 trig functions given a point where x is positive or negative and y is positive or negative is typically done by looking at your x, y, and your r values. Now your r value is going to be the distance from the origin to the endpoint, and so that's your r. Your x value is the same as normal, so this is a point xy. Now you can relate these three because x squared plus y squared equals r squared, or r is equal to the square root of x squared plus y squared. And you know that's a right angle. Also, this is your theta starting at the initial going to the terminal, and so you have your SOHCAHTOA as well. Your sine is y over r, and then you have a reciprocal function. Cosine theta, x over r, tangent theta, y over x. That's derived from SOHCAHTOA with these values. You have something called quadrantal angles. Quadrantal angles are where your point ends up on the axes. And so if you had a certain point, like this point, say it's 0, 2, the question is, what is the sine of theta where your point is at 0, 2? And your sine of theta, which is 90 degrees, would be equal to your y over your r. Now your y is the same distance as your r, so it's going to be 2 over 2, which equals 1. If I looked at 270 degrees, which is this point, and you can list it as 0, 1. In fact, this point doesn't really matter which one it is. It could be any point on that part of the axis. And so if you have that case, and the question is, what is the tangent of 270 degrees? You're going to remember it's y over x, which is the same thing as negative 1 over 0. That is undefined. Undefined is not a number. It is a concept. So you leave it as undefined, not blank, but as undefined. If the question is, what is the cotangent of 270? It would be the reciprocal of this, which is 0 over negative 1, and that, in fact, is 0. So quadrantal angles are ones that you can go ahead and graph and pull out your x, y, and your r. That's always what you're looking for in order to solve these problems, x, y, and r. Furthermore, when you're given certain points, you can evaluate these points and the 6 trig functions at those particular points. For example, 2, negative 5. So when you graph this, notice how I'm referencing the x-axis always. This will be 2, this is negative 5, and when you do the Pythagorean theorem, you get square root of 29. Now your r is always positive, so that's your x, this is your y, and this is going to be your r. Once you have your x, y, and your r, you're just going to plug those in. So here's your theta, and your sine is y over r, so it's going to be negative 5 over the square root of 29. Negatives are extremely important. Therefore, this is the reciprocal. Cosine is 2 over square root of 29. And the secant is the reciprocal. Tangent is y over x, and the cotangent is the reciprocal. This would be solved in the same way, again referencing the point in the correct quadrant. It'd be the first, second, third quadrant. Quadrants are labeled as you go around in a counterclockwise fashion. And therefore, this would be -3, this would be -8, and let's see, 64 plus 9 is 73. So that would be the square root of 73. Therefore, if you were to use this, again, cosine, for example, is x over r, so it would be -3 over the square root of 73. And the secant would be the reciprocal of it. And the rest would follow. So that's how you get the 6 trig functions given any point, and particularly being careful with the positive or negatives.